The air handling unit gives us the possibility to cool our premises, but the heat pump gives us the possibility to heat our premises too. Unlike the boilers, the heat pumps can pump the heat in and out side of your home. Just look at this video. So I'm cooling the premises now, or I can heat them if I want. The boiler only heat the premises, and that's great, but with the actual prices on gas, we have to think again. Plus, a heat pump runs very economical if it is properly installed. See, this heat pump have the possibility to warm up your home. It takes the heat from outside and it pumps it inside the home. This is a project I did. I found an outdoor and an indoor. I kept from the indoor only the printed circuit board, because the printed circuit board of the indoor instructed the outdoor to run either on heating or on cooling. Also, it will instruct the defrost and many other things. If you look into the indoor, you have to be careful. You have the room temperature probe, comfort probe, floating switch, condensate pump, fan, thermostat, flaps motors. All these things, you have to wire them correctly, and then you can use it for everything you want. By looking into this picture, what you will observe, the indoor have a printed circuit board. That printed circuit board from the indoor, which you see on the right hand side on the top, it controls the outdoor. So if you have the remote control, you will instruct the outdoor to start. This printed circuit board from the indoor can be mounted on anything. I choose to put it in a box, and I put properly the sensors where they're supposed to be. I can go deeper if you're interested. Just send me a message. So my first project was quite timid one. I got the outdoor, a plate heat exchanger. I calculate the plate heat exchanger. I use a pump. I calculate the water flow through the plate heat exchanger, and now the refrigerant is heating the water that heat a radiator. Later, I had courage to build a little bit a bigger system, and I cut the pipes from my boilers and I attached the heat pump. So the only thing I had to do, it is to extend the pipe. You see the red and this little pink pipe, and to connect the plate heat exchanger, which is near the outdoor. And again, I save the printed circuit board from the indoor, and that gives me a full control on outdoor. And I build my system, and I managed to get out 47 degrees Celsius with only 2.4 kilowatts. I managed to get 10 kilowatts. But that wasn't enough, and I was thinking about a cascade system. So this time I'm using two types of refrigerants. The outdoor unit need a refrigerant which run on a high pressure. So that will be a 32A refrigerant. That refrigerant 32A, it is cooled by the refrigerant 134A, which is inside the home. That's a heat booster. Why did I do this? Well, I think 47 degrees Celsius wasn't enough. And with this heat booster, I managed to bring the temperature up to 68. So for this system, I'm spending 5 kilowatts. The input is 5 kilowatts, about roughly 22 amps. But for this 22 amps, I'm getting 20 kilowatts. Can you imagine? So 20 kilowatts, it is a lot for the electricity I'm consuming. Technically speaking, if I would use an immersion heater and the heat pump will consume only 25% of the immersion heater. So if you want to heat your home with an immersion heater and you spend $1 as an example per kilowatt, with the heat pump you'll spend only 25p. So you will have a fantastic economy. So this system, as you'll see, you have the outdoor, then you have a plate heat exchanger that it's refrigerant to refrigerant temperature exchange, and then I have on the other side 134A, another plate heat exchanger which exchange the heat with the water. And then I have a pump which circulates the water through the system, and this is my heat pump system. So you always ask yourself, well, but guys, if you're refrigeration engineers, you can do this for yourself. If you find all the all the air conditioning equipment or some refrigeration, and you know how to do your calculation to choose the appropriate plate heat exchanger, you can really convert these outdoors in air water heat pumps, and they work. So this system is got on the left hand side the outdoor, in the right hand side you had the heat booster. If you don't use the heat booster, it will still work with only one plate heat exchanger, but you will not get 68 degrees Celsius. You will bring it up to probably 40 to 45. Let's say if you design a crazy system, you might reach up to 50, but that will be very hard. So I have the outdoor 32A refrigerant, and some of them run on 134A outside, but in winter they will not be efficient at all. So I'm using 34A outside, then the heat booster will be 134A, and 134A will heat the water. I fitted flow switch onto this water circuit to make sure that if the water is not circulating, the heat pump will not run. I don't want to overheat the refrigerant and to increase the pressure into the system. That's bad. And the thing is extremely easy. What I did, I cut the pipes from the boilers, and I fit this pipe onto my heat pump. You see, I put back the first version I did without a booster, and I managed to get out from 24 kilowatts electricity consumption, 10 kilowatts heating. If you lose an immersion heater, you will put 2.4 kilowatts, you'll get out 2.4 kilowatts. This one gives me 10 kilowatts for 2.4 kilowatts. So can you imagine if I will spend £1 on immersion heater to get the same power by using a heat pump, I will spend only 25p. So 75% economy, which is great. We will see that red pipe and this pink pipe that connects to the plate heat exchanger. If you remove the heat pump, you can put a boiler. It's the same thing. So my choice was to fit this heat pump instead the boiler, and it is working. The printed circuit board, you have to learn a little bit. Like if you have, as an example, a floating switch that would enable the pump, the cassettes have these pumps which eliminate water, condensate pumps. You got a floating switch, you have to use a little jump and then to make that switch redundant, but yet the PC board should receive the right instruction. Where's the motor? Instead to run the fan on an indoor, you can run your pump, the pump that circulate water through the installation, the heating agent. And also you can have a flow switch connected to the floating switch of the water pump, and then you will convert the system that way, so you run safe. Can you imagine if you do not have, as an example, water circulation through the system, then the flow switch will keep the circuit open, and the printed circuit board will sense that, and it will instruct the outdoor not to run, because you do not want to overheat the outdoor. So this is great. We will see that plate heat exchanger. On a red side the refrigerant is circulating very fast, and on a pink side is the water. Guys, thank you so much for watching this video, and I hope you enjoy a little bit. Think out of the box and try to do in this life your way, because life is a joy. Earth is the playing ground and we just play here.